Hey, what's up, guys? This is Chung. So this time, let's take a look at 1,349 maximum students taking exam. Okay, so you're given like a m by n matrix, right? Where has like the either a dot or a pound sign. So if this is a pound sign, it means that the seat is broken, and the dot means that you can sit here. And then your task is to place the student on this 2D on this m by times n matrix. But there's a rule that so the students can see the answers of those settings uh, on the left or on the right or on the top left or on the top right. So this is the example. So which means that if you want to place a student at the current location, so the left, right, and this top left and top right cannot have a student, and your task is to place as many students as possible. Okay, and then you need to return the maximum number of students you can place. Okay, so I mean this is like a very kind of like classic DP problem, you know. So for this kind of problem, we just need to like fill in the students from top down and from left to right. But I think the difficulty for this problem is that how can we maintain the status so that we can determine if we can place a student on the current location. So um, so I think there are like two type of informations we want to maintain. So the first one is a previously row status, right? Basically, we need to know the previous row which position on the previous row has a student or not, so that we can just check that. And second one is that we also need to maintain the current row status so far, so that we can check the left side. And then once we have moved to a new row, we can also like convert the current row status to the previous row status. Basically, we're rotating the current row with a previous row, since we only need the previously one row's status. So which means that the DP. So we need three variables or state. The first one is the position, right? That's the first one. And the second one is the what? Second one is the let's see a previous row, and the third one is a current row. So, and every time when we add like the a location position, we have a I and J, right? We just need to check uh, if those all four conditions are met. If and of course and the current one is a dot. If all those conditions are true, then we know okay, we can try to place the student at this location. Or we can another one is we can always skip that. Yeah, I think that's the basic idea. And we just need to get the maximum out of all the possible scenarios. So and to start the implementations, okay, so here's what we are going to do here. We have like m and n, right? That's that, and then the dp. Okay, so I think for this problem, I think the top down is kind of more straightforward. Okay, define dp. We have position, we have previous row, and we have a current row, right? So then we're gonna use the LRU to help us to handle the memorization part. Okay, so and then here in the in the end we just need to call it 0, 0, and 0 because at the beginning the position is 0. That's gonna be the 0, 0, right? And then the previous row and the current row they're all like 0. Basically, I'm using a bit mask to represent the the status of the previous row and the current row, since the constraint is pretty small, only 8 by 8. So there are like at most 8 columns, so it's more than enough to use like a bitwise, right? To store the which position has a student. Yeah. So so the first one is the base case. Let's say if the position is equal to m times n, right? And then we simply return 0, which means that we have moved the out we have processed all the the seats already. Then we can simply return 0. Otherwise, we just need to get I and j equals to div mod, right? The position with n, right? That's how we get I and j. So that's that. Okay, so and I think the next one we need to do is that, if j is equal to 0, so if this thing is at the beginning, right, of each row, right, update the row status. So what does this one? It means that, at the beginning of each row, we need to assign the current row to the previous row, and we need to clear the current row status. Since we have this kind of like rotating logic here, right? So at the beginning, the current row becomes the previous row, and then the current row will be 0 because it's a new start. Okay. And then we have answer equals to 0, right? So the first one is always not to place student here, right? So we can just do an answer equals to dp dot position plus 1, and then we have a so the mask that won't change, right? Because there won't be anyone here. So here actually there are like two scenarios. So either the current I and j is dot, or the current I and j is like the pound sign, but it doesn't really matter. So either way we're not placing a student here. That's why we can just use this one to handle those two cases. And the second one is the try to place student here, right? So if you're trying to do that, the first thing is that we have to check if the seat is a dot, is available, okay? It's equal to the dot, right? And after that, there is also like this kind of the edge cases where if the student is on mm, is either on the top row or on the left border or on the right borders. In this case, we only need to check the part of those 4 scenarios. For example, if the student is on the first column, on the first row, we only need to check the left one. If the left position has a student, and if this student is on the leftmost column, we only need to check the right side. Okay. And by the way, since we're placing the students following a sequence from left to right and from top down, there's no need to check the student on the right side, because on the right side will always be empty. Okay. So to make the coding a little bit easier, so I'm going to introduce like 4 variables, and which means that we have a top left equals to and a left, and top right and right. At the beginning, everything is true. Okay. And here in the end, right? So in the end, if the TL and L and TR and R they're all true, right? Then I can do this. I can place a student here, right? So which means they are going to be the max of the. By the way, so this R is always true, but I'm just keep it here so to make this code more clear. So we have answer dot dp position plus 1. That's the first one. And the previous row didn't change, but for the current row, right? So to place a student on the current location, it means that the current one has to be current bit value has to be marked to 1. So this one. So right, that's how we mark the current bit to be 1. And then don't forget to add 1 in the end, right? So which means that we're adding 1 of student. So here I'm just returning the answer. That's it. So now let's write the code to populate this 4 or 3 flag. And so I mean you can do many ways. So we can first check if the j is not 0, okay, which means that if the j is not the left, if j is not the leftmost column, then we can check if okay. So the left will be what? Will be the current row. Then we can check if the left one has a 1. So to check that, we just do a current row of the of this j minus 1, right? Since it's on the left side, if this thing is 0, and then this L will be true. Otherwise, if this one is not 0, then it means that okay, so there is like a person sitting on the left side. So that's then the L will be false. And here, if I is greater than 0, then we check if then the top left is like the previously row, right? Similar like this. And one we check the status of the previous row. If this one is 0, if this is 0, yeah, because we only need to populate this top left flag when we are not on the first row. Okay, and similar like the other one, which is if the j is not the last column, right? If j is not the last column, then we can check I think I'm missing something here. Uh, Here, yeah, I'm missing a parenthesis here. So on this side, right? So if the column is not the last one, then we can check the right side. But to check the right side, we only need to check the top right, which is this one, previously row and 1. We check j plus 1. Okay, if this one is 0, that's how we populate those 3 flags. Yeah, I think that's it, right? If I run the code. Oh, these are like, oh, I'm missing a colon here. DP is not defined. What? Oh my God, DP. Okay. So many typos this time. Okay, so now it's accepted. Submit. All right, cool. So yeah, it passed. I mean so the time complexity, right, is actually the time complexity will be what? Will be the position that's going to be m times n, right? And then times this pre-roll, so 2 to the power of 8, and then another 2 to the power of 8. So that's going to be the total time complexity for this problem. Yep. I mean, this one is like the kind kind of like a template problem. You know, the only thing we need to be careful is that how can we define the state, right? The state so that we can keep moving forward. In this case, we need two masks. One is for the previous row and second is for the current row. And then another one is that when we are at the first one, we have to rotate the previous one with the current one. And then other than that, it's just like some small trick to check if we can place the student at the current location. Yeah, so that's it. Okay. Yeah, I think I'll stop here. Thank you so much for watching this video, guys. Stay tuned. See you guys soon. Bye bye.